Okay, here's another example. Cite the phases that are present and the phase compositions for the following. The first one, 75 weight percent of tin, 25 weight percent of lead at 175. Okay, so let's look at this 75 weight percent of tin. So this is 100%, this is 80, this is 70. So 75 is probably somewhere here. Oh, the line is not so straight. Okay, and 175. 175, so this is 150. 175 is somewhere around here, probably 175. So this is the point. Okay, so cite the phases that are present. So what are the phase here? It's just the solid solution of alpha plus beta. Okay, next. At 4.5 mole of tin and 0.45 mole of lead at 200 degrees C. 200 degrees C is this, so it has to be somewhere around this line. But given here in mole, you need to convert mole into weight percent and then figure out the spot. Then only you can work out what are the phases present at condition number 2. All right. So let's look at how are we going to calculate the second part of the question. So in order to convert your mole into your mass, so this is nothing new to you. This is just the calculation of conversion. All right. So the weight or the mass of the tin is just 4.5 mole times its atomic weight. So you will get 534.2 gram. This is for lead, and for this is for tin, and for the lead, 0.45 mole times its atomic weight. You get 93.2 gram. This is for lead. Now that you got all this weight or the mass, so you can calculate the composition weight percent in weight percent. So for the tin, it's just this amount 534.2 divided by the total amount of the alloy. 534.2 plus 93.2 grams times 100, you get 85.1 weight percent. For the lead, also the same similar way, so you get 14.9 weight percent. And if you notice that since this is a only two component alloy, in order this one is actually 100 minus 85.1 weight percent. Okay, so you can double check your calculation using this kind of method. Okay, so now you know that your condition number 2 is you need to find the spot or the location of 85.1 weight percent of tin and 14.9 weight percent of lead. So 85.1 is probably around here. This is 80, this is 90, so 85 is around here, 200 is here. Okay, sorry, is here. So 200 is here. So what is the phase present? Beta plus liquid here. So we have solved number 1, we have solved number 2. This is beta plus liquid, and this is alpha plus beta. How about number 3? Determine the relative amounts in terms of mass fraction. Okay, when they mention mass fraction, automatically in your head you have to think of lever rule. of the phases in the above condition. So you need to calculate level rule for these two conditions, number 1 and number 2. So let's check out how they do it. Okay, for the first part, which is 75 weight% of tin at 175 degrees Celsius, the position is at this B point. Sorry. The position is at this B point. So this is for the first part, part A. Is it part A or part 1? Part 1, sorry. Part 1. Alright. So you need to draw a tie line crossing this B point, and you need to identify this C alpha, and this is blah 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 over here is C beta. So obviously C alpha is 16 weight% of tin, and C beta is here 97 weight% of tin. So this is for part 1, and this is for part 2. Okay, so this is what you need to calculate first. You need to find the composition of the alpha phase and beta phase. Now for the second part, which is this one, alright, which is for this condition. Oops, sorry. Oh, I'm so bad at this tablet. Okay, so this one is for the second part. So 85.1, so just now that I was mentioning, it was somewhere around here at 200 degrees C. So probably this point here, and you need to draw a tie line, okay? And you need to work out. This is for the CL. And this is for the C beta. Okay, so here is CB and CL. So for the second part, composition of the beta is just this point. You just drag down about 97.5 weight% of tin, and CL at this point here you drag down and you read about 74 weight% of tin. Okay, now we got all these two composition, and we can move on to the level rule. So this is where level rule takes place. Okay, this is the formula of the level rule I've given you before in previous slides. So you just plug in all the values that you have calculated for your alpha phase and for your beta phase. So this is for part 1, and this is for part 2. When I say part 1 and part 2, what I meant is this one, part 1 and part 2, okay? Because they ask you to calculate for both phases in the above conditions. We have two conditions here. The first one given as 75% of tin. The second one given is 4.5 mole of tin, right? So this is the part 1. So you just plug in all those values that you have figured out. So you'll get the fraction of both alpha and beta phases. And for part 2, you just plug in all the values that you have identified, and you will get the fractions for both phases, which is beta and liquid phase. Okay, next we have the final question. Determine the relative amounts in terms of volume fractions of the phase in part 1. But this one, they only ask us to calculate the volume fraction for part 1 only. So it's not so bad lah. Given the density for the tin and lead also. Okay, so the first and foremost, again, you need to use this formula to calculate for the density of alpha phase. So you use this formula and you need to work out what is the composition of alpha for teen and what is the composition of what is the composition of teen in alpha phase and what is the composition of lead in alpha phase. Alright, so you'll get 10.29 grams cm cube because you know here the composition of teen at alpha phase is 60 weight percent. So what is the composition of PB at alpha phase? It's 84 weight percent. Alright, here 84 weight percent. So now you get your density for the alpha phase. You calculate for your density in the beta phase, also using all the values that you have figured out. This is the composition of, I know that a lot of you might get confused with all these terms. So that's why I'm repeating it over and over again. So this is the composition of teen in beta phase. Let me just write it down. Composition of weight percent, yeah, of teen in beta phase, and this is the composition of teen in, oh sorry, it's not the composition of teen, composition of lead in beta phase. The volume fraction of the alpha phase and both the beta phase using the formula just now. Okay, so all you have to do is just plug in all these values inside this formula and you will get 0.21 for the alpha phase and 0.71 for the beta phase. Alright, another example, a hypothetical AB alloy of composition 55 weight percent B at some temperature is found to consist of mass fraction. Okay, given here mass fraction for both alpha and beta, meaning alpha 0.5, beta also 0.5. If the composition of the beta phase is 90 weight percent of B, given the composition of beta phase, meaning the composition of this is 90 weight percent of B, what is the composition of the alpha phase? So they are asking for what is the composition of this alpha phase, how many weight percent of B and how many weight percent of A. So let's check out on how we can do this. So here C naught, this is the initial given in the question, 55 weight percent of B, right? This one, this is C naught. And given here beta, which is this one, C beta. Okay, so you got this given in the question and also given in the question the mass fraction of the alpha phase and the beta phase also, which equals to 0.5. Okay, now if we set up the lever rule for this alpha phase, this shall be the formula, and this, you know that W alpha is 0.5, so you can work backwards and you can substitute all the values, you know C beta, you know C naught, and this is what you are trying to find out. So then solving for C alpha, you will get C alpha of 20, which is C alpha 20 weight percent of B. And how do you know it's 80 weight percent of A? It's just 100 minus 20. So you got 80 and 80 weight percent of A.